Alright, so once we use our table to find the standard deviation and variance of this data, the result will be this. So the mean that you're going to get will be 45. So once you get the mean, subtract 45 to each of these numbers, you're going to get this. This will be your deviation from the mean, and we know that if you sum all these numbers, the sum should be equal to 0. And then to get the mean absolute deviation, you take the absolute value of each of these numbers and then get the average. So the sum of these numbers is equal to 280. Divide this by 14 because we have 14 numbers here. So 280 divided by 14, we are going to get 20 as our mean absolute deviation. To get our variance, we need to square each of this, and then you're going to get these numbers. So when you sum everything up here, you're going to get 7,550. You get the average. Divide this by 14, you are going to get 539.29 as your variance. And then to get your standard deviation, you just need to take the square root of 539.29, and the result will be your variance, 23.22. Okay, now let's use our CASIO to find our standard deviation. So first, you have to go to Stat. Under List 1, you have to type in all of these numbers. 10,
30, 50, 60, 70, 30, 80, 90, 20, 30, 40, 40, 60, and then 20.
Okay, note that we have 14 numbers all in all. Next, we are going to press F2. We are going to calculate this one. And then press F1, one variable. And then note that the mean is equal to 45. And then the standard deviation is represented by this symbol. Okay, X sigma of n. So this will be your standard deviation, which coincides to the standard deviation that we got using our table, 23.22. Alright, so there we go. That's the shortcut on how to find your standard deviation. We don't really need to create our table, get the variance, and then the standard deviation. So we have now a shorter way on how to find the standard deviation. Now, to get our variance, once you have your standard deviation, what you can do is raise this to 2. So 23.22 raised to 2, and then we are going to get our variance, 539.17. Of course, it's not exactly the same because we cut off the significant digits in our standard deviation. But if you have multiple choice question, you know that the answer is pretty close to 539. Okay, for our dispersion park, okay, using our table, we will be able to get the following values. For our mean absolute deviation, it should be 8.57. Our variance should be 96.43, and then the standard deviation should be equal to 9.82. The mean is still 45. So again, let's try to use our CASIO to find the standard deviation. So just exit out, go to menu, go to Stat, delete all these numbers. So delete all, yes. Now type in all the numbers in here, 50,
30, 40, 50, 40, 60, 50, 40, 30, 50, 30, 50, 60, and 50.
Again, we have all in all 14 numbers. Press F6, calculate, one variable, and this will be our standard deviation, 9.82, which is the same thing that we got using our table. Now once we have 9.82, to get our variance, just raise 9.82 into 2, and we will be able to get our variance, which is close to 96.43. Okay, let's summarize what we have here. So the MAD for central tendency park is 20. For dispersion park is 8.57. So based from this, we can say central tendency park has more variability. Note that we have higher mean absolute deviation here compared to your dispersion park. It means that the data in central tendency park is more dispersed relative to the mean. If you use our values for standard deviation, note that my standard deviation in central tendency park is higher compared to our dispersion part. If we are going to use our standard deviation, we will get the same conclusion that the data in central tendency part is more dispersed relative to the mean. Okay, let's solve this question. For the central tendency part, how many elements fall within one standard deviation from the mean? Identify all the elements. So for central tendency part, this is the summary of values that we got earlier. For central tendency part, the mean was 45 and the standard deviation is 23.22. So how many elements fall within one standard deviation? So first, let's find your mean. Your mean is 45. It should be somewhere here. Okay, that's your mean. Your mean is here. Says one standard deviation. Our standard deviation is equal to 23.22. So I'm going to add 23.22 to my standard deviation. So you will have mean plus the standard deviation, which is 23.22. So you are actually adding 23.22 to your 45. So when you add these two numbers, you are going to get 68.22. So this is your mean plus your standard deviation, 68.22, and it is located somewhere here. Next, we subtract our standard deviation, which is 23.22 to 45, and the result that we're going to get is 21.78. So we got 21.78 by subtracting the standard deviation to our mean. So 21.78 is somewhere here. So how many elements fall within one standard deviation? So this is our one standard deviation. How many elements do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 elements. Identify all of the elements. So we have the elements are 30, 30, 30, 40, 40, 50, 60, and 60. So these are the elements within one standard deviation from the mean. Now what if we are going to answer this question? For the central tendency part, how many elements fall within one standard deviation above the mean? So above the mean, it means that all numbers above your mean, but it should be within your one standard deviation. So these are the numbers that are within one standard deviation above the mean. How many elements? We have 3 elements, and these elements are 50, 60, and 60. Alright, next question. Let's go to the dispersion part. Earlier we discussed the central tendency part. Let's discuss dispersion part. How many elements fall within 1.5 standard deviation from the mean? Identify all the elements. So again, this was the data that we got earlier. For dispersion part, the standard deviation was equal to 9.82, and the mean is the same thing, it's 45. So mean is somewhere here, 45. Now this time, we're trying to get 1.5 standard deviation. So I need to multiply 1.5 and 9.82. So 1.5 times the standard deviation, it is equal to 14.75. So we are going to create an interval wherein the mean is a center and the minimum of that interval is when we subtract this 14.75 from the mean, and the maximum of that interval is that when you add 14.75 to your mean. So let's subtract 14.75 to our mean. So 45 minus 14.75. Since we are identifying the elements that are within 1.5 standard deviation from the mean, I need to multiply. So 1.5 times 9.82, the result is equal to 14.73. Okay, so if I'm going to subtract 1.5 standard deviation to my mean, I'm going to get 30.27. So 30.27 is mean minus 14.73. And 30.27 is located here. Next, we're going to add 14.73 to our 45. We are going to get 59.73. And 59.73 is somewhere here. It's between 60 and 50. Now, 59.73 is mean plus 14.73. So how many elements fall within one standard deviation? So this is our one standard deviation. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. And those elements are 1, 2, 3, 4, 5, 6, 50. 1, 2, 3, 4, 5, 6. We have 2 40s. No, we have 3 40s. So this will be the elements. Next, what if we are going to identify, again in the dispersion part, 1.5 standard deviation below the mean? So we need to count those elements within one standard deviation but below the mean. So these are those numbers. So how many? We have 3. And what are the elements? We have 40, 40, and 40. Okay, so there we go. We're able to find the answer for these questions without even creating table. We can just use our CASIO to solve for our mean, standard deviation, and then the variance.